We are continuing 3.4 about using similar triangles. We know similar triangles have proportional sides and congruent angles. So if I look at these two triangles, I know that they have proportional sides. It tells me that their angles are congruent. These ones have 2 circles, these ones have 1, so they are congruent. And then corresponding sides are proportional. And I'm going to know that they're proportional based on where the congruent angles are. So this short side corresponds to the short side here. So 4 is proportional to 2. If I'm talking about A to B, we write it with a colon, and it's a proportion. So 4 is congruent, or 4 is proportional to 2, with a ratio of 2. 8 is proportional to 4. Those are both the median sides. And 12 is proportional to 6. Now, if I write them as fractions and find the values, I know that they are all the same proportion, which means that they are similar triangles. So I don't have to know anything about their angles if I know the sides are proportional. So let's determine whether these triangles are similar. So I have triangle A and triangle B. If I write my proportions A to B, I will have 2 to 5, 3 to 9, and 3 to 9. Writing them as fractions, I can see that 2/5 is not the same as the other proportions, so they are not similar triangles. The others reduce to 1/3. With these two triangles, find the missing side length. So now I know that they're similar, but I don't know everything about it because I don't know this x side. So to set up my proportion, there's a couple different ways you can do it. You can set it up where you have A over B, and this is where you use corresponding sides. So I could put 4 over 8 equals 5 over x. You need to make sure that one of your proportions includes the missing side length. Then you can cross multiply and solve for x. So 8 times 5 is 40, 4 times x is 4x, solve for x, and x is 10. That's one way. Or you can put A over A and B over B. And that would look like if I put 5 over 3, that's long side over short side, equals long side over short side. And again, cross multiply and solve for x. And x here is 10. So either way will get you the same answer. You just have to be consistent in how you set it up. Do I have corresponding sides, or do I have from A and then corresponding from B? With these triangles, we're going to find this missing side length of x. So if I put A over B, I can have 2 over 1, and then I need the side that corresponds with x, and that's going to be 7, because they are both the longest side here. And it's opposite of my 2 ringed angle, opposite of my 2 ringed angles. So I have 2 over 1 equals 7 over x, cross multiply and solve for x, and x is 3.5. You could look at it and say, well, I know to get from 1 to 2, you multiply by 2. To get from 2.5 to 5, you multiply by 2. So I have to multiply x by 2 to get to 7, and then you can solve for x there. I don't recommend that way. They're not always going to be that straightforward, but you could do it. You could use different side lengths this way, where you have 5 and 2.5, and 7 and x. Now what if my triangles are kind of stacked on top of each other like this, and I need to find x? So I have triangle A and triangle B, and if I put A to B, I have 9 corresponds to 3 because they are both with the right angle and opposite the small angle. So it's the same side without opposite the small one, 9 to 3. And then 8 and x are both the hypotenuse, which is the longest side. So I have x over 8, which is A over B. 9 is from A, x is from A, 3 is from B, and 8 is from B. So I have A over B. Then cross multiply, and 3x equals 72. Divide and solve for x, and x equals 24.